solder was much better in my opinion. I won't use to kill you eventually. It was, what we know. You got a nice glossy finish. You could see what you'd done. It shone. Modern solders don't do that, unfortunately. So what are we going to do today? Well, there are a number of stages or phases we're going to go through. First of all, I'm going to tell you, if you don't already know, some of you will, some of you won't. Forgive me those who already know. I'm talking on behalf of those who might not know. We're going to be looking through what soldering is, what you can achieve through it, how to do it. And the how to do it are practical. We've got some kits and bits and pieces here. First of all, we're going to make a very, very simple radio receiver. Incredibly simple, only 4 working parts. People involved in JOTA take note. Children can make these things that you're going to make today. That's a very simple thing to solder up. Second stage, we're going to go a bit more complicated. Having got a radio receiver that works, as it will do, won't it? Say yes, please. Yes, of course, that's right. We're going to build an audio amplifier so that we can all hear what it's receiving. And then we'll have a little speaker, we'll go through the process of building up an audio amplifier. And then in the third project, it has nothing to do with the first two because I couldn't think of any way of doing that, linking the two in. We're going to be making an oscillator, a digital oscillator, or rather a square wave oscillator. Some people call them practice side tone oscillators, Morse code oscillator. You can use them for that if you want to. But at the end of the day, it's just an experience of building something on a printed circuit board with small components. So we're going to start big, soldering things that are nice and big and easy. Then we're going to get a bit smaller. Then we're going to get a bit smaller still. But the question really is, why bother? I mean, back in the day, when I was a young man, yes, I was young once, believe it or not, you couldn't always get, thank you very much, you couldn't always get what you wanted. Today you can buy just about any device that you want in amateur radio, ready built, guaranteed, and cheaper than it would cost you to build it. There is a satisfaction, however, in it. But let me continue with just for a moment. This is something I built from scratch, and it's a dual band HF transceiver. Ta-da! You couldn't buy these when I started out, so I didn't redesign the circuits, but I designed the stages of it. So if I take the top off, these would normally be encased. There would be a case on the top of this and a case on the top of this. Okay, can you all see that? Ooh. And what it is, here we have a case which would normally have a lid on it, which is a variable frequency oscillator. Doesn't that sound posh? And if I turn the tuning dial, you can see this airspace capacitor slowly tuning there. It tunes through the bands. This is the ATU and SWR meter, which I did design. It was actually made myself. The PA sits underneath. That's that metal box at the bottom. Power amplifier, 3 watts output. Oh, whatever you need. And these are a side tone oscillator and a power supply on the back of here. These two here. So there was a time when you actually needed to be able, if you wanted to get all the things that you wanted. You don't do that now, you don't need it anymore, so why bother? Well, like I said, there is a satisfaction. The more you learn about this hobby, the more, to some extent, it becomes enjoyable. Conversely, the less you learn, the less satisfaction you tend to get out of it. So you get black box operators today who will buy everything they need, plug and play, stick it in a room and say, I'm a radio amateur. But what do they know about what's going on inside that black box? I suggest they probably don't know an awful lot. To be able to build, if you want to build, then you need to solder. And this is where we come back to soldering. Soldering. Many different ways of doing it. Different types of iron. This iron here, the tip, when it's plugged in and working, will come up to a temperature between 2 and about 350 degrees centigrade. Almost all solders will have melted within that range. This is another iron I use from time to time. It too, the tip will also come up to between 200 and 350 degrees centigrade. So why do you need different types, different sizes? If they both come to the same temperature, what's the need? Well, the need isn't in the temperature, it's in the volume. It's in the amount of heat. This is fine for soldering printed circuit boards, bits of wire, connectors on the end of wire and such like, for small wires. But this is something I need for another hobby I have, which involves much thicker wires. And so to get the wire up to the temperature needed for the solder to work properly, you need much more heat. So although the temperature is the same, the amount of heat, this is an 80 watt iron, that's a 20 watt iron, so this produces 4 times more heat. So the bigger the device that you're going to solder together, the more heat you need, the bigger the iron. And how does solder work? Right, I'm going to come over to this side here. Let's imagine, and I'm not very good at drawing arms.
That's not whiteboard.
Shit, isn't it?
I don't think so. No, I don't think so.
It works like a whiteboard.
Oh, well, maybe it is, but I don't think so now, to be honest. I think
Is
that's
that a whiteboard?
Well, let's scrape it.
Yeah, okay, let's try that.
You call it local head. 50.8.
that good or bad.
That's an organic important.
It's not working. Something's not right.
Oh. Might you get yours somewhere?
You saw this stuff. This is copper-clad board. It's glass fibre with a coating of copper on one side. This is quite commonly used in home brewing. You're right there, Pat.
Yeah.
You're not going to die on this, are you? Do you know what? I didn't bring a bloody picture. I can't believe it. Yes, I did. There it is. Island. It's called Island, as in I-S, not I-R-E. Can you see that? Whoa, that's difficult to see, isn't it? Ah, it's very difficult to see.
We close the blinds, we should be able to see that.
I'd say
What lights?
no, I think that's what it is. Yeah.
Oh, yeah.
Is that any better?
Yeah.
Right. So this is copper-clad board, fiberglass with copper etched onto one side. And what they've done is they've made up little islands of other copper-clad board. It's just a piece that's been taken off the edge and cut into squares. And this person, I bought this because he's a very neat worker, and I am not a neat worker. But look, what he's done, he's got black lines he's printed over each little island, and they're physically stuck to the copper-clad board. It is copper-clad board, but it's stuck to the board from the little pieces. And this enables you then to solder. This is a resistor going onto here, and obviously he has a wire then going to this little island here, and another wire going up to that little island there, which has a resistor across it. And the benefit of copper-clad board is that the copper itself forms an earth plane. Certainly when you're dealing, if you're making anything at VHF or higher frequencies, having an earthing board is very useful. So if you can see, I don't know how well, this resistor here, its one end is on an island, and the other has been soldered directly to the copper-clad board. So the board is acting as an earth plane. It's at 0 volts, it's at ground RF. And this capacitor is soldered to the board. This capacitor is soldered down to the board. It gives you a very good earth plane, if you understand. So, can I put the lights back on again? And what we're going to actually do is solder the ends of the coil to the two islands on the edge of the board. Okay? But we need to do what's known as tinning, or the Americans call it wetting. So for this you will need a hot soldering iron, so now's a good time to start plugging the soldering irons in. Let's have a crystal set. Nothing personal, but I'm going to use yours, all right?
Hopefully it works.
Hopefully I'm having so too. Right. So,
No,
we use...
no. I saved that from the other day.
We'll put that to one side. Then we'll use another one. Did it come off? I've got an earth connection down here, which is to the heater, hot water radiator heater. Which will act as an earth. Oh, look. said, the shed on there. That one goes on there. Hopefully. Come on. Ah. Absolutely so. Bastard. It's a good job I didn't bluff it and say, oh yes, I can hear video with a PCB. And the contacts come through on the other side. Now there's another type of board, other than perf board, called Vario board, just to tell you this, where the holes are connected in rows, but they're all connected together. With perf board, none of them are connected. So we're going to do what's called through the hole, because you put the wires through the holes of the board, through the hole, point-to-point wiring. Through the hole, because it goes through the hole, and point-to-point wiring, because we simply link up the wires when they poke through the other side. You can't tin the wires of these components, you can't pre-solder them, because if you do, the solder won't go through the hole. The solder on the wire makes the wire go through the hole, so we can't tin them, so the soldering becomes a little bit more difficult when we get to the other side. The first thing we're going to do is to put in an earthing rail, and somewhere over the horizon.